Hey Ramblers, this video covers chapter 12.1 in our textbook and deals with the surface area of prisms. Now surface area is going to be broken up into two kinds of area. We'll call that lateral area and the areas of the bases. And we're going to learn tonight about prisms, which are a type of polyhedra. So we're going to learn a few definitions, go through the formulas for these two types of areas, and I hope that you will start to keep a separate formula sheet, much like you did in chapter 11. I really think it'll help you when you study for the quizzes and the tests if you have all of your formulas in one place. And just like chapter 11, there's going to be a lot of formulas. Okay, so take careful notes, pause often. I hope this helps. Thanks for watching. To understand prisms, we have to look at them in the broader context of polyhedra. Prisms are a kind of polyhedron. All of the solids pictured here are polyhedra. And polyhedra are defined as solids with flat faces. So even though some of these solids in the back appear to be almost spherical, you'll recognize that they still have flat surfaces that are polygons. Now as we move to the front of the solids pictured, you can see that some of them have sharper corners. And these are prisms. Prisms are special kinds of polyhedra. A prism is a polyhedra with two parallel faces called bases. So you can see that this regular prism pictured here has a triangular base on top. The lateral faces are parallelograms, and then down at the bottom is the other base, which is again a prism. All prisms have two bases that are congruent and parallel. Make sure that's in your notes. All prisms have two bases that are congruent and parallel. The prisms are named for the shape of the base. Where bases meet lateral faces is called a base edge. So this triangular prism has three base edges on top and three base edges on the bottom. The faces meet at what are called lateral edges, or you could look at it as an altitude. There are three lateral edges and three lateral faces in this triangular prism. Okay, let's take a look at some other kinds of prisms. As you can see, we have a hexagonal prism whose bases are two hexagons, a pentagonal prism whose faces are two pentagons, and then a rectangular prism. And rectangular prism, it's a little bit difficult to recognize what's the base, because in a prism, all of the sides are parallelograms. And in a rectangular prism, the bases would also be parallelograms. So it's a little unclear with rectangular prisms. It's a little ambiguous as to what's the base and what's a lateral face. That's not terribly important. Everybody understands the ambiguity. There's one other phrase that comes up when we deal with prisms, and that is if a prism has a lateral edge that meets a base edge at a right angle, it is said to be a right prism. So this would be a right rectangular prism. The right does not refer to the angles of the base. It refers to the fact that the lateral faces meet the bases at right angles. So this would be a right pentagonal prism. None of the angles in the pentagon are right angles, but the lateral edges meet the base at right angles. Okay, let's take a look at two very important definitions relating to area. Now, the first is lateral surface area. Lateral surface area is the sum of the areas of the lateral faces. Now, you may have just calculated the area of each face in the past and added them up. But I'd like you to use a new formula, and I'll show you that in some of the tutorials, how it's just quicker. The lateral area, which I'll abbreviate as LA, equals the perimeter of the base times the altitude. The total area is the sum of the lateral area and the area of the two bases. The formula for total area is the lateral area plus 2 times the area of one base. Because once again, in a prism, the two bases are congruent. So we only need to find out the area of one of them and multiply it by 2. Okay, Ramblers, there's two tutorials that really show you the shortcut for figuring out lateral surface area, so I really invite you to watch them. Rewind the video if you missed anything. Thanks for watching. To summarize GeoVideo 12.1, we introduced a lot of vocabulary, so let's go over some of that. The first word was polyhedra. Now, polyhedra were solids with flat surfaces. That's pretty general. So in this video, we talked about prisms. Prisms were polyhedra with two parallel and congruent faces called bases. Now, the bases served to name the prism. They all had lateral faces, which were parallelograms. The bases met the faces at what were called base edges, and all of the lateral faces met at what were called lateral edges. Now in this chapter we're going to be interested in finding the area, the surface area. And surface area can be broken into two types. The first type of or subset of surface area was lateral area, and that was the sum of the areas of the lateral faces. The shortcut that I want you to use in this chapter, because it's just so much quicker, to find lateral area was the perimeter of the base times the altitude of the prism. And of course, you'll recall the altitude and the lateral edge were the same thing. The second subset of the surface area was total area, and that is equal to the lateral area plus the area of the two bases. Okay, Ramblers, I hope all this is in your notes. Tutorials will follow. Thanks for watching. Number 3 on page 563 is a typical problem from this chapter. It asks us to find, in A, the prism's lateral area. Now you'll recall that the lateral area is equal to the sum of the lateral faces of the prism. And in that case, you might be inclined to just add up the area of each one. So you could say 11 times 17, and that would be the lateral face that's coming toward us, plus 11 times 17, which is the lateral face facing away from us, plus 11 times 16, which is the face on the bottom of the triangular prism. Well, notice that if we factored out the common 11 to all of these, we'd be left with 11 times 17 plus 17 plus 16. Now hopefully you notice that this is the altitude of the prism, and this addition here represents the perimeter of the base. So you'll recognize that the lateral area really is the height times the perimeter of the base. And when we multiply that out, we get 550. All right, in part B, they ask for the area of one base. Well, we're going to go back to what we learned in chapter 11, and we're going to drop an altitude because we recognize that this is a isosceles triangle, and so an altitude to the base will bisect the base. So now I have an 8, 15, 17 right triangle, so the height is going to be 15. So the area of one base is 1/2 the base, which is 16, times the height, which is 15. When we multiply that out, we get 120. So in order to find the total area is going to equal our lateral area plus 2 times the area of the base, which was 120. When we add all those up, we get a total area of 790. Okay, that's number 7. Let's take a look at another one, because I think it'll really help you with this lateral area formula. Okay, number 8 on page 564 asks us to find the total area of the right prism shown. Now again, right prism just means that the lateral faces and the base meet the base edges at right angles. So this L-shaped prism is standing right to the ground, and in order to find the total area, we'll first have to find the lateral area. Well, you could calculate the area of all of these different faces, including the ones you can't see in the back, and that could be done, but it'll get a little confusing. So let's use the perimeter of the base times the height. Well, the perimeter of the base is going to be 2 plus 4 plus 5 plus 2, and then we have to add that side in the back, which is going to be 5 plus 2, and then we'll have to add this other side in the back, which is just going to be 4 plus 2. So for our total perimeter, we have to add on another 7 and another 6, and we'll multiply that times the height of 7. So when you multiply this out, you get 6, 11, 6 times 7, which is 182. Now to get the total area, I have to add on the area of the two bases. So I'm just going to multiply 2 times one of the bases. And one base I'm going to break up into two rectangles. This rectangle is going to be 2 times 6 plus the other rectangle, which is going to be 2 times 5. So I'll end up with 182 plus, which is 182 plus 44, which comes out to 226. Okay, the important reason to see this problem is I'm urging you to use this lateral area times the height formula. Perimeter of the base times the height formula in order to find the lateral area. I think it avoids a lot of confusion as the problems get complicated like this one. Okay, Ramblers, thanks for watching.